Okay, so ready to start. So hello and good afternoon, everyone. Thank you all for joining us today. I hope everyone is safe and well. My name is Denny Martin, and I'm the Aftermarket Technical Support Specialist and Product Line Manager for Embraco North America. And I am pleased to present today's webinar, The Trend of Natural Refrigerants in Commercial Refrigeration. Today we're going to have a very important presentation, not only for technicians and engineers, but also for anyone who owns or works with any refrigeration equipment that uses a flammable refrigerant. It's a very popular topic that our speaker has been presenting all over the US with great attendance. Thanks to our customers and partners who have opened their doors to us. Therefore, many of you have already had the opportunity to meet Matt Sopp, our speaker for today's training. This webinar is part of a NEDEC Global Appliance Initiative to share technical content during this tough period we are facing around the world. We have been promoting webinars in 4 different languages: Portuguese, English, Spanish, and French. Today's webinar is actually the second training of a webinar series. The first webinar went live on June 4th, and we discussed the refrigeration system, the compressor functionalities and main components, as well as good practices for compressor replacement and common compressor failures and causes. It is available on demand on Embraco's YouTube channel. You will have the opportunity to watch and share today's webinar through this same YouTube link on the Embraco channel. Matt Sopp, our speaker, will go through the presentation for the first 40 to 50 minutes, and he will answer questions in the last 15 to 20. You can leave your questions and comments in the YouTube chat, and we will do our best to reply while we are live. And now it's my pleasure to present Matt Sopp. Matt Sopp is a key account manager with NEDEC Global Appliance and represents the distribution and aftermarket segment for the Embraco brand in North America. Previously, Matt was a nuclear mechanic in the U.S. Navy for 9 years and served on the USS Augusta, SSN 710. He has worked as a mechanical maintenance planner at the Braidwood Nuclear Generating Station, where he created work packages for preventative and corrective maintenance, as well as major engineering changes and projects. He also performed root cause evaluations and audits to analyze human performance equipment failures and evaluate for process improvements. As a previous technical specialist at Embraco, Matt worked on training and technical support for HVACR contractors and technicians. As a sales engineer with Trane, he assisted with the design of HVAC system solutions for industrial and commercial customers. Okay, Matt, we're ready to start with you.
All right. Thank you very much, Denny. And thank you to everyone who has taken some time out of their Thursday to join us today. Before we get started here, I'm going to go ahead and turn off my camera. Hopefully we can keep from crashing the session. And give it a quick test, Denny, just to make sure are the slides visible and can you hear me okay? I'm going to assume that that's a yes, and just go ahead and get started.
Yeah, looks like we can see everything just fine, Matt.
Okay, thank you. So the topic for today, as Denny mentioned, is natural refrigerants, and more specifically, we will focus on R290 propane and R600A isobutane, which are the two most popular refrigerants for light commercial refrigeration, the compressors that we're manufacturing. And the big item is right here in the middle of the screen, the safety and practical. That's really the goal of this entire presentation, is just to talk about how to safely work with these refrigerants. But we'll also touch on the new legislation and some of the things that led to us using these refrigerants, and then specifically why natural refrigerants over some of the other potential alternatives. We'll touch on the compressor changes and really just try to look at the entire system and see what's different and then what's still pretty much the same. And again, most importantly, we'll talk about the safety aspects of working on these systems, and then we'll touch on a compressor replacement towards the end. There is a video mentioned here. We will not watch the video today, but there is a link at the end. So I encourage you to click on the link and check out the video once we're complete. So for the new legislation, one of the biggest things out there these days that's causing confusion with our current refrigerant landscape in the U.S. is when we look at this screen, we see that it says California Air Resources Board on the left-hand side. When I started working on this presentation a few years ago, it used to say EPA SNAP program. And back around 2016 and heading into 2017, it was the plan of the EPA to ban some of the refrigerants that we see on the screen here, like 404A, 134A, 507A, and then several of the 407s. Before they had a chance to do this, they were taken to court by a couple of the refrigerant manufacturers, and the court found in favor of the refrigerant manufacturers. But it wasn't that they didn't want the EPA looking out for our environment and for our industry and trying to move us forward. It's more of a procedural issue in how the EPA was trying to ban these refrigerants, and that they weren't allowed to do bans in the manner that they were trying. And so that got put on hold officially, which would have been a nationwide ban. But then immediately after that, states like California and then Washington and then several others that we'll look at on a map here in a minute all began to just pick up and pass the same legislation that the EPA was trying to pass. And so at this point, it can be a bit confusing, because instead of looking at a nationwide constant around the country, I guess, legislation or the bans or anything, how you would consider that for what refrigerants you can use in light commercial refrigeration, it's going to be state to state, and there's going to be variances by the states. And we'll start off by looking at a couple of them specifically, but just as a startup here too, when we get to the screen that has California on it, you'll see some of these A1 and A2s and A3s next to the refrigerants, just so that everyone knows what these mean. These are the safety classifications for the refrigerants. And so an A1 is going to be a low toxicity with no flame propagation. This is going to be the refrigerants that you're used to, 134A, 404A, any of those. And A3 is going to be what we're looking at today, the R290 and R600A. You'll likely also see one on there that's an A2L. And what the A2Ls are is an example would be 1234YF, which is what about 80 to 85% of the automotive industry is using at this point. They are going to have low flammability, but the L is a new classification as we try to make new refrigerants that have low global warming potential. Most all of them are turning out to be somewhat flammable, and the A2L classification is just a little bit of a subcategory in those A2s, where there may be slight variances in the burn velocity and in how much heat it takes to cause flammability with that gas, how much gas you can have in the area. And so that's what that L is going to be. It's just a little subcategory. You won't see any of the Bs, the high toxicity gases listed here, but what those are going to be is maybe an example of a B1 would be R123, which is used in some centrifugal chillers, or a B2, I believe B2L actually, ammonia, which would be high toxicity and also flammability. Then you can see here just some examples, R22, 404, 134, all listed as A1, so low toxicity and no flame propagation. And then compared to the ones that we're going to discuss today, R600A and R290, which are still low toxicity, but with a high flame propagation. So starting here with California, we'll just start on the left-hand side in the banned substance table. You're looking at R134A and R404A. And so the goal of the legislators and the goal of what they were trying to do here was to lower this GWP number which is the global warming potential number. And so just the easiest way to think about that, this may not be exactly right, but an easy way to think about it is if you had R134A, it would be that given the same amount compared to CO2, it would be 1,430 times worse for the environment, for warming in the environment than CO2 would. CO2, carbon dioxide, the one that we always hear when we are reading the news, watching the news about global warming and climate change, it's your baseline, and it's going to have a GWP of 1. So keep that low number, that 1, in mind as we look at the next chart over in the middle, which shows the EPA final rule. It's not actually the EPA final rule, but this is what it was going to be, and this is what California has adopted. And so you can see in that second column, it starts to get a bit more confusing because R134A, now there's multiple different options for replacements, and the same thing for R404A. But the one big difference that you'll notice, well, a couple big differences you'll notice, I guess, is some of these numbers, the global warming potential numbers of these replacement refrigerants are still pretty high. You look at R450A and 513A, and they're still greater than 600. And on the portion below, 448A and 449A, it's almost 1,400. So in those two cases right there, it's almost as much as R134A, which was already banned. The other thing you'll notice about those is that those replacements that have a higher GWP also are still class A1, so no flame propagation. But then when you start to look at the ones that have much lower numbers, R600A and R290 with a global warming potential of 3, R1234YF, the one that I mentioned for automotive with a global warming potential of 4, you get to those really truly numbers, and most of them are going to be flammable, at least a little bit. And so you can see that with that classification there. So when it came to us, a company that manufactures compressors, and as we started to work with the OEMs out there and trying to figure out what direction to go when it came to what sort of equipment to make, the goal was to get to the lowest GWP number possible. We didn't want to design a compressor specifically for something that still has almost 1,400 GWP, knowing that that's likely to be banned in the future as well. So while those are great interim refrigerants, and that's what we call the ones that have the higher GWP values, they're not the ones that we would consider to be a permanent solution. We're really hoping that R290 and R600A, since we've developed compressors for those and OEMs have developed equipment for those, will be more permanent solutions than the others, which will be more interim. And that seems to be proving true with some states, specifically California, are already looking to ban refrigerants that have a GWP that high. And so they are perfectly legal to use right now and good alternatives. But there is a chance that those will be banned sooner than later. And so that's one of the big reasons why we started to look at some of these A3 refrigerants out there and move in that direction. As we get to the far right side of the screen, you can see the types of systems that we have these bans on, such as supermarket systems, remote condensing units, standalone retail units, and vending machines. And you can see that they kind of happened in different dates. It was going to be the same way with the EPA bans, and everything just got pushed back a couple of years once it started to be adopted by the states. They had to have a couple of years to get everything adopted and written into legislation. But these gases are now banned in all of these types of equipment. And that's for new equipment. That's not for service. But an example there might be with a supermarket system. New equipment would count if you made some sort of alteration to a system, you did an addition. And so now your refrigerant charge size has changed and it's increased. That's going to be considered a new system at that point. And so really at this point, you can really only use the older refrigerants for service. As we switch slides here, we're going to go next to Washington State. And you can see it looks very, very similar to what California did. The only difference that you'll notice is if you look to the block on the right-hand side of the screen, the dates are a little bit different. So supermarket systems up there at the top that said 2019 for California, it just starts at 2020 for Washington. They were a bit behind California when it came to getting their legislation implemented. And then we'll look at Canada. And for Canada, it's very much the same thing. You can see the two blocks on the left-hand side didn't change. The refrigerants that are being banned are still the same. Some of the basic replacements in the middle there are still the same, and that's just a beginning list. That's, of course, not all-inclusive, but you can see how it starts to get confusing, but it's still the same ones. What Canada did different is they already have a few other dates in here that we've included, such as chillers and mobile refrigeration systems, motor vehicle air conditioning, and domestic refrigeration are all included over here, and they weren't included in the ones for California or Washington. And as I mentioned at the start here, part of the reason that this can be so confusing is because of where the changes are taking place in a state-to-state fashion. I apologize for the colors on here. It does make it hard to see, so I'll try to explain this a bit, and then you can also see on the key off to the right-hand side. But California and Washington, as we looked at, have already passed their refrigerant bans that just mirror what the EPA tried to do in 2017. Vermont and New Jersey are also there. It's passed and they're finalizing regulations. New York, Massachusetts, Connecticut, Rhode Island, Delaware, Maryland, and Colorado are all working on and finalizing their legislation. And then even the other ones that have kind of a light gray tint to them, maybe something like North Carolina or Virginia or Montana, New Mexico, Illinois, Wisconsin, the ones that are those colors there, they're also working on banning these same refrigerants in their states. They just won't make it in time to have the bans implemented in 2021. So it will be beyond that time. And then as you look at the rest of the map, the colors of Florida and Georgia and Alabama, Texas, all the states that are colored that color, as of right now, there is no plan to adopt these refrigerant bans. And so it's very confusing at this point to know what you can and what you can't use, especially if you're in a place where you're in multiple states throughout the week or throughout the month. And so my recommendation, because we just aren't going to get that deep into refrigerant landscape in this presentation, is to find a good refrigerant training and definitely keep up to date with that, because until we finally see something that passes through Congress and allows the EPA to make these bans on a nationwide level, then it's going to stay a bit confusing like this for the foreseeable future. Another reason that we started to look at new refrigerants was at the same time that the EPA was changing their standards. We had the DOE energy standards here, and E-Star for commercial appliances were being updated in 2017. And so as we look at these and we compare back to what they were in 2010, you look at an upright glass door freezer here on the right-hand side of the screen. And in 2017, it was going to need to produce 57% less, or have 57% less energy consumption than the standard of 2010. The horizontal solid door ice cream freezers, 53% less energy consumption. On this screen, bottle coolers, 48% less, and professional kitchen equipment up to 50% less. And so at this point, this wasn't as easy for the OEMs as just coming to Embraco or Nidec and saying, please make us a newer, more up-to-date and more efficient compressor. They were going to have to start looking at the entire system. And so the entire system would, of course, include the compressor and then other things like ECM motors and LED lighting. But then it also includes the refrigerant. And as we'll see in a couple of slides, the refrigerant is much more efficient than some of the older refrigerants that we've just banned. So why natural refrigerants? The first one, as we discussed on the previous slides, is that low global warming potential. We wanted to follow along with what the legislators were trying to do and put ourselves in a position where we felt like it was going to be the most permanent product that we could make. And so we wanted to go to these low GWP refrigerants. As I mentioned just a minute ago, they are energy efficient as well. So we use this medium glass door merchandiser. There's an estimate out there several years ago that we had about 1 million of these throughout the US. And so it makes for easy math for us here. But we'll look at an R404 unit, and then right next to it is going to be an R290 unit. And that R290 unit is going to consider using R290 refrigerant and having LED lighting and ECM fans. And so that first line, you're going to go from 1,194 kilowatt hours per year down to 810. So nationwide, you're looking at 384 million kilowatt hours per year that no longer need to be generated in our power plants. When it comes to how much money we're going to save, $119 operating cost for an average operating cost down to $81. So $38 million across the US when you look at all the equipment that's out there. And then when it comes to that legislation for global warming and for climate change, we have about 5,000 million pounds of CO2 potential equivalent warming over a 10-year period. And so we're really also hitting that target as far as getting after what the legislators were looking to do with climate change. And so it checks off a lot of blocks here. And this is just for medium glass door merchandisers. So you can start to imagine as you change out more and more equipment and make these changes, just how much that adds up. We also say that they are safe. Luckily, here in the United States, we do not move very quickly when it comes to these changes. We have the EPA, and we have UL, and we have ASHRAE, and we have fire codes. There's a lot of different things out there that have to be changed, and a lot of committees that have to meet, and a lot of agreements that have to be made before we actually make any of these changes. And so we're well behind the rest of the world when it comes to this. The good thing about that is that everything that's in this presentation that deals with the safety aspect of these systems comes from other parts of the world and from our colleagues in Europe, and it's all tried and true things, that changes that they have made. And so it's not us just sitting around thinking and trying to come up with good ideas. It's actually things that have been put into place in other parts of the world and proven to be successful to keep safe when working on these systems. The other thing I want to touch on this slide is it shows the small amount of charge. So right now in the US, our legal charge limit is only 150 grams or 5.3 ounces of R290. And so that's going to be somewhere between 2 to 3 cigarette lighters worth of R290 if you have the full charge available in the piece of equipment that you're working on. Just as a note, we did make a change last year. There's one of those committees I mentioned, the IEC, which is the International Electrotechnical Commission, which is about 140 to 150 countries from around the world. They got together last year and decided to increase that charge limit to 500 grams, which is around 17.6 ounces. However, here in the US, that has not gone through. At this point, we still have to have all these meetings and decide exactly what we want to have our charge be. If we want to go all the way to 500 grams, if we want to maybe stop somewhere in the middle and do 300 grams, or if we don't want to make a change at all. And so those meetings are taking place right now, but it could still be a couple years or even more, just depending on how this all goes on approvals before we see any changes. But I do like to mention it now so that at some point, if you're working on a piece of equipment in the future and you see that it has larger than a 5.3 ounce charge, then that's why you're seeing that change, is they have finally gotten around to making that change. Some additional benefits that we see when we made the switch on some of these refrigerants is right here, just looking at the temperatures. So when you look at the shell temperature on the left-hand side of the screen, going from R404 to R290, and then a couple of those HFO blends in there, you're looking at a 30 to 30 plus degree difference in shell temperature. So you've gone down significantly in shell temperature. And then you see the same thing on the right-hand side of the screen in the discharge temperature when you compare to those same refrigerants. And so that lower shell temperature and lower discharge temperature, we're expecting to have a longer compressor life, a lot less wear and tear on the compressor and on the system in general. There's also a reduction in the refrigerant charge. As we just mentioned, 5.3 ounces is the maximum charge for right now. So obviously it had to be less charge required to be able to keep using these same types of systems. And so you can see here when you're going from R404 on the left-hand side of the screen or R134 on the right-hand side of the screen to R290, you're looking at about a 45 to 50% reduction in charge. And R134 in the middle of the screen to R600A, about a 35 to 40% reduction in the required charge. One of the big notes on this is it definitely could help with the service costs at some point. When I started to do this presentation a few years ago, as I traveled around and talked to some of the wholesalers out there, you would often see these little 14 to 16 ounce canisters of R290 for anywhere from $250 to $300. And as I travel around now and talk to the same people, usually that small little canister is anywhere from about $18 to $40, $45. And so in just that 3 years, it's come down that much. And we are just starting to see some of these pieces of equipment come out of their warranty period and start to be worked on more. So this is something that's just really getting started in the aftermarket world. And as they get worked on more and more and that supply starts to increase, hopefully we'll see the price come down even potentially a little bit more. And then finally, for the last reason of why natural refrigerants, the big thing with all those other advantages, the low GWP, the temperature differences and the longer compressor and system life, everything that went along with, we also could meet most light commercial applications with the existing 150 gram or 5.3 ounce charge limit. So it kind of made it easier to go that way since not too much extra had to be put into the design of these pieces of equipment when it came to that charge limitation. You will note on the bottom portion of the screen there, the bottom left, in some cases, some companies have designed equipment with multiple circuits, and that's a thing to get around that 5.3 ounce limit. But as the charge size changes, you'll likely see that stop happening here in the near future. So for the compressor changes, right here, it looks like there's a lot of changes, but I think you'll see as we go through that it's very, very similar actually to what we've been producing before. The big difference is going to be this bottom one on the screen here, these electrical components. So right here, we're looking at a medium back pressure application and just comparing the required compressor displacement to an R404 and an R134 compressor. And the displacement needed is going to be a bit bigger compared to R404 and a little smaller compared to R134. So right in the same area. As we switch slides here, we now switched it to a low temp application, low back pressure. And it's the same thing. It's usually a bit bigger than 404 and a bit smaller compared to R134. The big thing to keep in mind here is that the external dimensions of the compressor are going to stay the same. Nothing there had to change because of this change of refrigerant. And then as we look at the operating pressure, it's kind of the same story here. It's going to be a bit lower than R404A and a bit higher than R134A. So definitely nothing like a switch to 410 or using CO2 or anything like that. Definitely similar pressures to what you're used to seeing. This is where we have the big change here, is when we look at, this is that IEC on the left, these IEC standards. So we're looking at the maximum refrigerant charge of 5.3 ounces that we currently have, at least for the US. And then the big one that's going to have an effect on our systems here are these two, which is explosive atmospheres and electrical apparatus for explosive gas atmospheres. And the easiest way to describe this is just to look at a picture. And if you look at the right-hand side of the screen, you're looking at a 3/4 round or a Clix-on overload protector for maybe one of our R134A compressors. And then on the left-hand side of the screen is what that same overload protector is going to look like for one of our R290 compressors. And so it's very much the same piece of equipment. It's just everything has to be sealed where there is the potential to produce a spark. And that's what those standards are getting at, is the requirements for sparking components and how everything needs to be sealed, and then the different types of testing requirements and everything else that needs to be done on these cabinets to make sure that you're never going to have a spark in an area where there could potentially be R290 refrigerant if there were to be a leak in the system or something like that. So as we look at the entire system, the big change that you'll see to let you know that it's going to be a flammable gas inside the system is going to be up here on the top, this little sticker. So you'll see that caution, risk of fire R290 sticker on one of our R290 compressors. Another requirement of the EPA here in the US is to have a red sleeve on the process tube. So you're going to see a red sleeve or pink sleeve or red paint or something like that. It's going to be identified. And so as a technician walks up to that cabinet, those should be the first two things that you see that are going to alert you that it's been designed to have a flammable refrigerant inside. But outside of that, the condenser is going to be very similar. It might be a bit smaller to accommodate that smaller charge. Same thing with the evaporator. The piping is going to be similar, and the filter dryer is going to be similar. You'll want to make sure that you have a filter dryer that is compatible with R290. The capillary is going to be pretty much the same. It may be slightly longer. The expansion valves and the fan motors and the fan blades and other electrical components, as we get to the bottom portion of the screen here, that's where we're going to get into the things that are different on an R290 system, and everything has to be specific for these cabinets. And so the fan motors need to be spark-free. The fan blades are going to need to be plastic or an aluminum material that's non-sparking. And then all the other electrical components are going to have to be approved per that IEC standard, and they're going to have to be non-sparking electrical components in the system. When it comes to lubricants, R290 is totally miscible with POE, alkylbenzene, and mineral. What we had made our compressors with was with POE and alkylbenzene. So you will see both of those out there. I believe at this point that we have changed, and now we are just using POE with our R290 compressors. But just as a note, you'll see a couple different ones out there, and I can't speak to what some of the other manufacturers may have done. So always best just to check the label plate on the cabinet or the compressor data sheet, something like that, to make sure that you've got the right lubricant. and for the safety stuff, obviously the most important part of this presentation. The big one right up there up top, common sense and staying alert when working with these refrigerants just goes a long way towards keeping safe, knowing that you have a flammable refrigerant and trying to keep a lookout for anything in your work site that could potentially produce a spark, knowing that there may be a flammable refrigerant in the work site. Probably one of the biggest ones here for us, the second bullet, is to develop work procedures that keep in mind the flammable nature of the refrigerant and follow them on every job. And so I don't necessarily mean that I want you to use that work procedure on every job that you know has a flammable refrigerant in it, but I want you to use it on every single job. And part of the reason that we recommend this is in these next two bullets here. The first is that hydrocarbon refrigerants don't have an odorant. As we see later, they are extremely pure, and the requirement on them in a system is to have a very, very pure refrigerant. And so they're going to be about 99.5% pure R290 or pure propane. And there's not enough extra space in there to have an odorant. And so you're not going to be able to walk into a work site and identify if there's been a leak by the smell. Also, the other reason on this bottom bullet here, every time I do this presentation, I'm always asked about any incidents or accidents that have taken place, and if anyone's blown up a piece of equipment or if people have been hurt working on it, and all those kind of questions. And if you go looking for incident reports, when people are, a technician, for example, is walking up to a cabinet and they see the label and they see the red process sleeve and they know that there's a flammable refrigerant inside that cabinet, and then they still got hurt, something still went wrong, you won't find too many of those. Those are not common out there. But the ones that you will find many, many more of is when there's an illegal refrigerant that's in that system and there's a flammable component to it, or when someone puts a refrigerant into a system where it's not supposed to be, and then a technician walks up and they don't know that that change has been made, or they don't know that a refrigerant with a flammable component is in there. That's the accidents that you'll find the most. And so what we want you to do is to develop that work procedure where maybe the first thing that you do on every job is to walk up and before you do anything else, pull out your combustible gas detector and check the work site to see if there is any refrigerant in the area. And then before anything else, even at that point, open the door, check on the inside of the cabinet and see if there's any combustible gas inside the cabinet, and then unplug the cabinet and go to work on the system. We also want you to leave that combustible gas detector running the entire time that you're working on the system, so that you always know if any residual gas inside the system leaks out, you can stop your work and then you can continue from there. So these are the kind of things that we want you to put into a work procedure that reminds you that it's not always just going to be the cabinets that are designed for flammable refrigerants where you may find one. And that is the incident reports that are out there. They're not common, but it is something that happens. And so as you saw at the beginning of this presentation with all of the potential replacement refrigerants, there's a lot of them out there, and there's just getting to be more and more and more. And so we just want to make sure that everyone stays safe when they're working on these systems. Another thing to go along with that bottom bullet down there is it is actually illegal to take R290 and to retrofit it into a system that it's not designed for. So you couldn't take R290 and put it into an R404 or R134 system. Those systems, everything about them has not been designed and tested for having a flammable refrigerant on the inside. And so all those electrical components and everything else that I discussed, they're all going to be potentially spark producing. And so it would be very dangerous to put one of those refrigerants into the wrong kind of system. So as we look at this slide, it's trying to tell us how we create a flammable mixture of the refrigerant on our work site to try to give you a better feel for exactly how you could get this gas to ignite. And so we have the lower explosion limit and the upper explosion limit. And we're going to stick to R290 on the far right-hand side of the screen. And so what it's telling us here is this lower explosion limit at 2.1% is that we need to have 2.1% of our atmosphere be R290 in order for it to be explosive. And as we go through this, keep in mind as well that these refrigerants are heavier than air. So if there is no circulation, air circulation or anything like that, they will tend to just settle down to the ground. But the easiest way to think about this one is if you could seal off the room that you're in right now, and you could then pump R290 in. And so you've got a little bit of propane in your room now, And let's say that it's equally distributed all throughout your space, but you only have 1.5% of your atmosphere is R290. You don't have enough there to have ignition. And on the flip side of that, the upper explosion limit of 9.5%. So now you've sealed off the room that you're in, and you pump in a bunch of R290, and let's say that it's 12% of the atmosphere of your space is R290 equally distributed through. And now you've got too much R290 to have an explosion. So it does have to have the right flammable mixture, the right atmospheric requirements for it to be explosive. On the right-hand side of the screen here, we have some dimensions on an example room. And I know it's in meters if you're looking at it, but basically what it's saying is if you could take a space that's around 5 feet by 5 feet by 6 feet. So that would be a very weird size space. It would be kind of me tall by me wide by me deep. Not a very typical size space. And if you could take a system that had 5.3 ounces in it, you could pump the entire 5.3 ounces into that space and have it equally distributed through. You would only get to about 1.85% of your atmosphere in there. So you would want to really drive that percentage up to get in between your lower and upper explosion limit. You're going to have to shrink your space down a little bit. And as you shrink it down, you may end up with a space that's about the size of the inside of your cabinet. And so it definitely is the most likely place on a job site to have a flammable mixture of R290 or R600A is going to be on the inside of the cabinet, which is why we mentioned before with that work procedure, checking the outside of the space for a leak that may have happened, but also opening up the door and checking the inside of the cabinet before you do any work, just to make sure that you don't have R290 in there as well. It's also very important when we think back to those electrical components, because hopefully by the time a technician shows up on the job site, something has tripped that unit. If you had, say, a catastrophic leak and all the refrigerant leaked out inside the cabinet. So at this point, it's off. And by the time you get there, hopefully you're following your procedure and you check your work site, and then you check the inside of the cabinet, and you would find the refrigerant all sitting at the bottom of the inside of the cabinet. So you could just open the door, get some ventilation going, and then let that ventilation pump that R290 out of the space. But where it could really be dangerous is if somebody came along and they put the wrong fan blades or fan motor or thermostat or anything like that, any of those electrical components inside that cabinet, and then there was a catastrophic leak and all of the refrigerant leaked into the inside of the cabinet, and you did have a spark producing component on the inside, then that's when you could get a ignition event with the refrigerant and with that cabinet. So that's why this is very important to remember that you do have to have the right requirements, but then also it just ties into those electrical components and to make sure that you're always using the correct electrical component with these cabinets. Another example of this too, just to kind of give you a bit more of an idea of how this the gas works, is we had some engineers into our office. I believe it was the UL engineers that tried this out, if I'm remembering correctly. And they tried to actually test this theory out with the room to see exactly how the gas would work. And so when they pumped the room full of R290, and it's now about knee deep after it's had time to settle, everything at the bottom of that space is going to be a very, very high percentage of R290, way above 9.5%. So it's not going to be flammable down there. And everything at the top of the space is going to be well under 2.1%. And so it's not going to be flammable up there either. And when they tried to light that to see what would happen with the gas, it did exactly that. And the only place where it would burn is it would kind of trickle along the top of the layer of R290 at the bottom of the room, because that was the spot where you had just that little bit of atmospheric mixing and you were falling between 2.1 and 9.5%. And so just as an example of how the gas works, and that it isn't just inherently explosive all the time, that you do have to have the right conditions to have a flammable mixture. So some precautions for service. We always want you to do a risk assessment. And this might be something that you would put at the beginning of your work package, of your work procedure, just to see if it's appropriate to use a flammable refrigerant in that space. And I always get some funny looks when I say this, but we want you to have a 10-foot radius around the piece of equipment that's being serviced that is free from sources of ignition, such as open flame, electrical devices, light switches, all those kind of things. And I know that they do not design commercial kitchens to have 10-foot spaces around all of the equipment, but it's just our recommendation to try to get as far away from any of those sparking electrical components as possible. But especially all the time really, but especially if you can't get that full 10 feet, we want you to have a fan with you and have air blowing across your work site so that you always have ventilation. So in the case that there is a little bit of leakage out of the system into your work site, that R290 is just going to disappear and be gone, and it's going to just go out into the rest of the space, and it's going to be such a small percentage of that space that it would never be a flammable mixture. We, of course, always want you to wear excuse me, PPE on every job, but especially when working on these systems. And then the two things, or one of the things I just mentioned there, the good ventilation. And then also, as I mentioned before, having that hydrocarbon detector or the combustible gas detector and leaving it at a low level so that if you do have a leak out of that system, it's going to fall down to the ground, and then you're going to know that there's a leak coming out of your system in your job site. So you can see the little note on the fan here. It says to have a fan rated for explosive atmospheres, and that's, of course, definitely the recommendation for the fan. And as you'll see in a slide or two here, also for all of the tools that we are going to have on these job sites. But I know that that's probably a very expensive fan. But if you can't have one of those fans, having circulation at all is better than not. And so if you put a fan 10 to 15 feet away blowing across your work site, you're still going to have plenty of ventilation coming across your work site in case of any sort of leak. So definitely just ventilation of any sort is better than none. But if it is a potentially spark producing fan, keep it away from your cabinet. Then, as I just mentioned, that really goes with all of the tools that you're going to be using on a job site. We want you to have a vacuum pump that is specific to hydrocarbons, and we want you to have spark-proof tools, and we want you to have an anti-static electricity tag, and also a recovery machine here, and recovery cylinders that are specific for hydrocarbons. You can see the note here in the middle of the screen. A standard recovery machine is going to have potential sources of sparking, such as the switches and the pressure controls and relays, all these things. So if you're finding that you're having to recover the gas, then we recommend using one of these, and also the recovery cylinder, because it's going to have different compatibilities, these gases, with the valve seals, and then also different pressure ratings and things like that compared to the cylinders that you're currently using for 134A or 404A or one of those types of gases. And so you need to have a specific cylinder. Oh, the other note I was going to mention on this slide is when it comes to that recovery machine, these gases, because they have such a low global warming potential, you can vent them. And so we're finding that a lot of people are just choosing to vent instead, especially with that small charge. Sometimes if you're not able to vent in that area, people have been able to take a hose or a piece of tubing and route it so that it's out the door or out a window or something like that, and then they can vent that way. And then you'll just know that you're done venting by using your combustible gas detector. Where we're seeing specifically that people are having to recover is maybe more when it is a specific customer requirement. An example being at a grocery store or something like that, and that chain doesn't want you to be venting propane inside the store or something to that effect. And that's where we're seeing that most people are having to recover. So just as a quick example for the replacement of an electrical part inside a cabinet, we would want you to sweep the work site with your combustible gas detector and then open the doors and check in there as well. Then disconnect the main electrical supply. And then for right now, as I mentioned before, how important it is with those electrical components, we want you to replace the failed electrical components using OEM parts. And the reason that I say that now is using a thermostat, for example, you might normally walk into a wholesaler and buy a Ranco or a Johnson Controls thermostat or something like that. There's just not a lot of those components that are available in the aftermarket at this point. And so if you're not able to find it, the recommendation is to go back to the OEM for now and just get the parts from them and use those parts to be sure that you have the correct non-sparking parts for that cabinet. And again, just to reiterate, the inside of the cabinet is going to be your most likely area to create a flammable mixture. But on the external portion, you just never know. Something like a built-in system, as it says here on the screen, might increase your possibility by trapping gas in a certain quantity in a certain area. And so that's why we just always say to always have that combustible gas detector going the entire time that you're working on the system. I'm not going to go through every bit of the next few slides here, but what we're trying to say is on these, you're developing these new work procedures, and you're having your combustible gas detector out there, and you're bringing ventilation out there, and you're taking all these extra safety precautions. And so we really want you to do as good a job as you possibly can to make sure that you diagnose the entire system, because a lot of the compressors that get pulled out of systems are still good compressors. I think the number is around 50% in the aftermarket. And it may be something like an internal overload that's being stubborn and taking way longer than it should to reset, or something to that effect. And oftentimes also, just even if it is a compressor that has failed, there's going to be something else going on inside that system that has put stress on that compressor and caused the compressor to fail. And so we really just want you to make sure that you do a good full system diagnosis, and make sure to fix all the problems, since you're having to go to so much extra work in the first place just on those safety requirements. We don't want you to get a call back and have to go back out and just change out that compressor again. For the compressor replacement. So another thing here, this little data sheet on the right-hand side of the screen, it's sort of the same thing I mentioned from before. Just making sure with these cabinets that you have just follow the label plate of the OEM, and maybe get the data sheet of the compressor. There's a lot of good data on here. It's kind of hard to see because it's so small, but it has the start and run winding resistances, and it has your voltage ranges, and it has your like a locked rotor current, and then it has the oils and spare parts and electrical diagram and everything that you may need to help troubleshoot that system. So very useful. And of course, two of the things here that I've mentioned already several times, I'm sure, but use the hydrocarbon gas detector when you get to that job site, and then leave it running in a low area the entire time to monitor your site. Provide ventilation over your work site. And then the one that I haven't mentioned, but also equally as important, to post a safety placard or a safety sign that lets everyone else that isn't you know that there's the potential to have a flammable gas in that area, just so that everyone is aware. And even if you're taking all the requirements, that someone else doesn't come along and do something that may cause an unsafe environment in your workspace. For the actual replacement here, I'm just going to try to hit some of the highlights because as we go through, I think you'll see that it looks very similar to a normal compressor replacement. But number 2 here, try to ground the cabinet if you can. Just one more thing to try to avoid any potential sparking. We also want you to vent from the high and the low side, just in case that there is any sort of clog in the cap tube or in the filter dryer. And then the big change on this screen compared to a normal compressor replacement that you would do is that you can vent the gas. And so just to do that risk assessment of your work site and see if you can vent where you're at, see if you can maybe route that hose to vent out a door or something like that, or to find out if you need to recover. And so then the big thing here, as we discussed before, is if you can't safely vent in the area that you're in, having that correct recovery machine and the correct recovery cylinders, just to make sure that you're going to be safe as you're performing that recovery process.
Hey, Matt, can you hear me?
Yes.
One quick thing, it seems there's a delay between your presentation and what I'm seeing on YouTube. When you change, if you can just give it a second or so to let it change, there's a little bit of a delay.
Oh, sure. Yeah, thank you.
Thanks.
Let me go ahead and pull everything up here so we can see it. So for this portion here, you're going to see that it's pretty typical. The big thing is we want you to try to cut the compressor out using a tubing cutter. If you must braze, the big difference that you'll notice is that we have a couple 50-pound nitrogen purges, just really trying to make sure that we get all the R290 out of that system. And then again on number 13, they're of course having a 1 to 2 pound purge during the brazing process, just to really try to displace any residual R290 that may be in that system. And then for the installation of the new compressor, it's going to be pretty much the same here. Again, we want you to do that 1 to 2 pound nitrogen purge as you braze. And then the big difference here may be with that filter dryer, just to make sure that you have a filter dryer that is going to be compatible with R290 or with R600A, if that's the system that you're working on. Then on this one, as we discussed before, the big thing on this is going to be number 7, and then the little bullet that's off to the side over there. We just always want you to use a refrigerant that is labeled R290 and not just propane. So the Blue Rhino from your local grocery store is great for the grill in the backyard, but definitely not for your refrigeration system. Those just aren't pure propanes. They have the odorant in there, and they're going to have moisture in there, and there's going to be all sorts of things that are bad for your refrigeration system. And the little bullet on the right-hand side there, as you can see, it's going to tell us that a 1% degradation in the purity of your R290 can lead to a 3 to 6% degradation in system performance. So just going from that 99 or 99.5% pure R290 to 98%, it doesn't seem like it's that big of a difference. It's going to bring your system down 3 to 6% from its optimal performance. In the big gray square in the middle, there's a couple other just recommendations that we have when it comes to, things like weighing in the charge. Make sure that you use that label plate and a digital scale and try to weigh in the charge to be as accurate as possible, because it is such a small charge in these systems. Same thing when it comes to using the very small charging hoses. I'm sure you've seen at this point some of those charging hoses available out there that are only about 12 to 18 inch long, and they have a 2 millimeter ID. They're very, very thin. And so very different than having like a 6-foot charging hose where you could lose your entire charge in there. And so things that aren't required necessarily as you work on these systems, but definitely recommended to try to be as accurate as possible on the charge and just prevent any sort of callbacks that may happen from not getting the accurate charge in there. I am frequently asked about failures that we have and that we see in these systems. And are we seeing any compressors fail or any specific problems or anything like that? And we're really not. The biggest thing that we do see is the problems that come from not having an accurate charge in the system. So if this last one has loaded up here, a big thing on this one would be to meter in the rest of the charge from the charging and low side hose to the system as you get started up there, just trying to be as accurate as you possibly can with getting your full charge into the system. And then one big final note in this little box on the bottom, if you go watch the video that we have that I definitely recommend watching, at the very end, you'll see that they braze the process tube to seal up the system once the refrigerant has been installed and the system has been charged. And everyone always asks, did they braze on the system with R290 in it? And they did. And that's definitely been the guidance that's been out there up to this point. I highly recommend you go out and search around on Google and just try to find other guidance out there. But if you do that, you may find something from True and you may find something from Coke. And there's a lot of good PDFs out there that will show you the steps that a lot of companies want you to take and how to work on these systems. And all those will show you brazing the system to seal it up. And when we had the UL engineers and some of those same OEMs that I just mentioned into our office last year, and we were discussing this, they recommended that instead of brazing, using something like a lock ring system. So you're doing a no braze compressor changeout. And I think the guidance there is just, if people are going to be uncomfortable brazing on a system that has a flammable refrigerant in it, to just avoid it altogether and to go with a system that's going to allow them to do that compressor change out without any sort of brazing. And so there are systems out there like lock ring that are available so that you can do that and do a braze-free compressor change. And so I just recommend looking those up and looking into them and seeing if that's the method that you would prefer to do. One note on that, when it does come specifically to the lock ring system, there's like a compound or a glue or whatever you want to call it that goes along with that system. And we did have a bit of a problem with that where people were putting a bit too much of that compound onto the joint, and it was eventually working its way into the compressor and then causing the compressor to fail as it gummed up the piston. And so anytime you're using one of those, I just always recommend to make sure to follow their instructions, the manufacturer's instructions, as closely as possible, and try to have it be as accurate as you can to make sure that everything goes smoothly with your compressor installation. And then here we have the video and a little recommended reading. Our refrigeration club, you can go and check out that site, and there's a lot of R290 and R600A information there, and I definitely recommend it. Also with the video was shot in our factory in Brazil, and it's in Portuguese and dubbed over into English, so it's a little bit goofy when it comes to that aspect, but it has a lot of good technical information in it, and I do recommend just checking out the video. Because they're in the factory and they were trying to highlight all of the technical aspects of the changeout, they weren't focused on highlighting the safety aspects because they were in a known space. So I definitely recommend as you watch the video to try to think about all the things that we discussed, like having the hydrocarbon detector and having your work procedure and getting your ventilation started and having your safety placard up and all those types of things that you would do on one of these job sites, and just fill that into the video. And while you're there, we have another one that I also highly recommend for compressor failures, and it's our quality department, and they will crack open some compressors and show you what happens to the compressor when there's moisture introduced into a system, or when the system doesn't get a correct charge and there's too much refrigerant in the system, for instance. And they'll actually show the inside of the compressor to show you what happens when those things happen. I definitely recommend that video as well. And that's all we have at this point. So, Denny, I'm going to turn it back over to you. And I think we have a couple minutes for a couple questions. And then any questions that we don't get to today, we will, of course, answer over the next few days and get answers sent back out individually to everybody.
Yep, absolutely. Matt, thank you very much for sharing this important content with us. And as always, for explaining it very goodly, very well. Thank you. So we have several interesting questions. I've tried to answer as many as I could in the chat, but let's see here what we have. We had one good, I thought was good here, and I think we did cover it, but it was concerning the vacuum pump. Does the pump have to be a spark-free pump?
So it doesn't have to be a spark-free pump necessarily. You could definitely use a longer hose, use that 10-foot hose and try to get the vacuum pump out of your work area. But I think as it's going to be with every tool that you will use on these systems, we, of course, will always recommend that you have a spark-free version of that tool, because is one reason, just an easy reason, is we get more and more of this equipment out there, and we start to work on more and more of this, and it's not going to be just a few fringe items and that you'll rarely bump into. It's going to be millions of pieces of equipment across the country, and it's just going to get to be more and more as we go forward, especially as more states start to ban these older gases. You're just going to have equipment out there everywhere, and so you're going to be making use of all of these tools as you buy them, and you'll be using them forever. And there's just going to be more and more components inside your work area, so maybe inside of a commercial kitchen, that all have these gases in them. And so we just want you to be as safe as possible. And so it's definitely always going to be our recommendation to use these spark-proof tools. Denny, do you have any other comments on that one?
No, I think that pretty much covers it. I think that's our stance, is if you're going to be working on these systems quite a bit, you might as well just go ahead and invest in the spark-free tools. I think it would be the best way to go. Matt, thank you. I have one more that I was kind of curious about. The question is, what about controls on flammable hydrocarbon systems like high pressure switches, fan cycling controls, and such?
Yeah, everything on those is going to have to be designed to be spark-proof if it was spark-proof before. And it just depends on the component. A thermostat, for instance, it may be able to produce a spark, but it might not. It just depends on each individual component. And it's going to be like that for everything in these systems. And so there's a lot of testing and design work that goes into these, from the OEM level to the UL approvals, where they look at the entire system and they try to cause leaks in different areas and see how long the R290 is going to sit over top of certain components, and if you're going to make it to the lower flammability limit, or what percentage you're at, and exactly how these gases are going to flow if there is a leak. Just everything you can think of like that goes into the design of the systems. And so it's going to be the same thing when it comes to anything that's potentially an electrical component. A lot of them won't have to change. We saw that 4TM type overload in the middle of the presentation, and those were already inherently safe. They didn't produce a spark. They were already sealed. We just had to have that proven and tested by UL to show that it was a safe component. And so I would just think of that when you think of these systems, that everything's been through that testing. And that's also why we're recommending at this point that for anything on these systems, until you see things in your wholesalers, to just go ahead and go back to the OEM for any components that you may need.
Right. Sounds good. And the only thing I would add is, as far as the pressure switches and the fan cycling controls, they will have to be specifically tuned for the different pressures for the specific application and refrigerant you're using. But I didn't think about the spark-free component of it. So thanks for clearing that up, Matt.
Yeah, and like you said, definitely for the pressures as well. We saw those charts. The pressures and everything are very similar, but they are different. And so everything's unique about these systems compared to previously. So,
okay. And we're almost out of time, but I'm going to squeeze one more in here. We have the question, why is horsepower never on the compressor technical data sheet? And Matt, if you want, I'll go ahead and take this one.
You can go ahead and do that one.
First thing I'll say is we do include it on our spec sheets on most of them. But the main reason is a very generic way of sizing a compressor. In my opinion, compressors should always be sized by capacity at the specific rating point that you're using it in, because horsepower can range through a pretty large range of BTU capacity. So that's kind of why probably some manufacturers avoid the horsepower rating. And with that, Matt, if you don't have anything else to add, I think we're pretty much out of time. I hope everyone found this webinar as interesting as I did. Again, Matt, excellent work presenting this important content and also clarifying all those great and relevant questions. Thank you all so much for connecting and staying with us until now. And again, this webinar is part of the NEDEC Global Appliance Initiative to share technical content during this challenging moment when we must stay at home, taking care of our health and the health of our loved ones. Thank you, Matt, and thank you all for joining us this afternoon. Take care, everyone.